Okay, so today we are doing experiment 2 pre-lab calculations, and basically what I've done here is I have copied the pre-lab questions that can be found in your lab notebook. So we are going to go through and do these questions, and the reason we are doing these calculations is because they will be exactly like the calculations that you will do when you're in lab completing experiment number 2. Okay, so we have a beaker of water and it's sitting in a pan on an electronic scale. It gives us a reading of 110.4 grams. Okay, a lead weight hanging from a string is suspended in the water, and the mass reading on this scale increases to 127.9 grams. Okay, the lead weight then falls from the string, rests on the bottom of the beaker, and the reading becomes 309.4 grams. Okay, now there are 5 questions that we have to answer with regards to this information. Okay, so question number 1, what is the mass of the water displaced by the lead weight? Okay, so with this, what we're looking for is we originally have a reading of just the beaker of 110.4 grams. Okay, and if we read the next sentence, it goes to 127.9 grams. So basically, all we have to do is subtract these two numbers. Okay, so we would have 127.9, and we would subtract the initial amount of just the beaker. Okay, now, since this is a subtraction problem, we know with significant figures that we have to line up our decimal points, and we have to draw our line to show where which number has the fewest digits past the decimal place. Okay, so now we can do this calculation, and as we go through, we calculate that we have 17.5 grams. Okay, so we have just determined what is the mass of water displaced by the lead weight. Okay, so we have 17.5 grams. Now, the second part of the question asks us what is the volume of water displaced by the lead weight. Okay, now we already know that the mass of the water displaced by the lead weight is 17.5 grams. Okay, but we want a volume. So how do we get from a mass unit to a volume unit? Well, basically what we have to do is we have to use a density. Okay, and although it's not given in this problem, earlier in your introductory readings for experiment number 2, we saw that for water, 1 mil is equivalent to 0.9982 grams. Okay, this is a conversion factor that enables us to convert from grams to milliliters in this particular instance. So basically we're going from a mass unit to a volume unit. Okay, now since we want to get rid of grams and we want to be left with a volume unit, we know that we have to set up our conversion factor where we have 1 mil on top and we have our grams on the bottom. Okay, that way grams cancels out, we're left with milliliters, and when we do this calculation in our calculator, we get 17.5 milliliters. Okay, now we're looking at this, we say, okay, we know the mass of the water displaced by the lead weight, we know the volume of the water displaced by the lead weight. The next part of the question asks for what is the volume of the lead weight, and they are exactly the same. If you did your pre-reading for the introduction of experiment 2, you see that the volume of water displaced is also going to be the volume of the lead weight. So this one, we don't even have to do a calculation for, okay, because they are the exact same. Okay, now in terms of the mass of the lead weight, well, initially in the problem, it gave us a reading of 110.4 grams. Okay, that was just the beaker. Then the last sentence says that when the lead weight falls from the string, rests on the bottom of the beaker, the reading of the electronic scale becomes 309.4 grams. So in order to determine the mass of the lead weight, we simply have to subtract these two numbers. So we would have 309 0.4 grams, and we would subtract the initial reading, which is 110.4 grams. Okay. Now again, because this is a subtraction problem, we have to line up our decimal place, and we have to draw our line to show where our significant figures are going to cut off. Okay, so when we do this, we end up getting 199.0 grams. So 199.0 grams is the mass of the lead weight. Okay, so we've determined the mass of the water displaced. We've determined the volume of the water displaced. We've also used that to figure out the volume of the lead weight. So we have the volume of the lead weight, we have the mass of the lead weight, and then we can use that to determine the density of the lead weight. So since we already have density, if it's looking for the density here, we know density is mass over volume. Okay, well, we have our mass, and up here we have our volume. So by simply dividing, we can determine the density of this lead weight. So we have our mass at 199.0 grams. Okay, and I am going to divide the volume. So since I'm dividing, I'm just simply going to flip that volume upside down. So I would have 1 over 17.5 milliliters. Okay, and as you can see, we go through our units, grams over mils. That's exactly a unit of density. It's a mass over volume unit. Okay, and none of them cancel out, so after we do this calculation, we end up getting 11.4 grams per milliliter. So this is the density of our lead weight. Now, in terms of significant figures, we see here, this has 4 significant figures. This here has 3 significant figures. So since we are dividing, we know that our final answer must have 3 sig figs. Okay, so this is the type of calculation that you will be doing when you complete experiment 2. You will be doing this for various materials, and basically you will be taking these materials, using a beaker full of water, determining the amount of water displaced, determining the volume of this object, determining the mass of the object, and then ultimately determining the density of the object. So these calculations are very important. You will use them in experiment 2.